Hi everyone, and welcome to lesson 1.3, which is measures of center and spread. So in the last class, we talked about how to describe a distribution, and we want to remember that whenever we're asked to describe a distribution of a quantitative variable, that we want to talk about three characteristics, which are shape, center, and spread. Today we're going to focus on how to actually quantify the word center, and we're going to look at a way to quantify the spread of our data values as well. Okay, so let's talk about two measures of center, which we're going to look at, which are the mean and the median, and when it's appropriate to use either of them. So if a distribution is unimodal and symmetric, which if you'll recall, unimodal and symmetric means that it has one mode, okay, so one peak in the data, and symmetric means the same on both sides. Usually unimodal and symmetric histograms will look something like this. Okay, so I would consider that unimodal. It's got one mode, which is where the peak is. That's the value that occurs the most. And then we have, if I was to slice this in half vertically, it would be approximately the same on both sides. So when that occurs, it's best to use the mean or the average to describe the measure of center, okay? So let's take a look at these 6 students, and we want to calculate the average. So how do I find an average or a mean? To do that, we are going to take the values that we have, and we're going to add them, and then we're going to divide by the number of values that there are. So I'm taking those 6 numbers, and I'm going to add them up, and I'm going to divide by 6. Now, when I'm doing this, I'm finding a sample average, okay? Because we know that the class may have more than 6 students, but let's say the instructor picked 6 random students, okay? That would be my sample. So we have 2 types of mean. We've got a population mean, which would be the entire class, and then we have a sample mean, which would be the sample of students. Whenever we're looking for the sample mean, we're actually looking for this symbol called X bar, okay? When we're dealing with a population mean, we are looking at using the symbol mu. So we have 2 types of means. The population mean would just be the symbol mu. So that's a Greek symbol, it looks like a U. And then this is the sample mean. Because it's a sample of students, we're looking for X bar. So it's the sum of the test scores for those students divided by the sample size, which would be 6. There are 6 students there, okay? Now, we actually have, a formula for averages or means. And when we say sum, that's the Greek symbol sigma. So sigma means add. So we're adding up all the values, and then we're dividing by the number of values that we have. Okay, so if you look at any kind of formula sheet, you'll see this formula for average. Anytime you see this Greek symbol, which is sigma, sigma just means sum. So you're going to sum or add the values and then divide by the number of values that there are. Okay, so I'll show you how to find this on the calculator as well. So if you have the TI-84 Plus, there's an easy way to find the average. If you go to Stat, which is 2 buttons to the right of the green button, and then Edit, so just hit Enter, and you're going to type in your values. Okay, so the values that I have there, again, are 87, and then just hit Enter, and do that for all the values. Okay, now notice that I have my 6 numbers. If I want the calculator to calculate the average, you could just add those numbers and divide by 6. or you can go back to stat and this time click calc, C-A-L-C, and we have one variable here. The variable is test scores, right? That's quantitative, it's numbers. It's probably in points or percentages. And you can hit enter, and you don't have to worry about typing anything next to frequency list. As long as the list says L1, which is where you typed your values, you're okay. And then hit enter. And when you hit enter, you'll see these statistics pop up. And if you look at the very top, it says X bar, that's my sample average, is 80, okay? Right underneath that is sigma X, so that's the sum of all those values. So if you were doing this by hand and adding up those 6 values, you should have gotten 480. And of course, 480 divided by 6 does give you 80. So the average test score for that sample of students then is 80. Okay, so sigma X was 480 divided by 6, and I got 80. Okay, so this is known as the mean or the average. The mean is great if your data values are, when you graph your distribution, if it comes out to be unimodal and symmetric. Okay, so bell-shaped kind of. So that just means the typical grade on this exam was about an 80. Okay, but let's say a 7th student gets placed into that data set and they scored a 5 on the test. What's going to happen to the mean? So if you have an average of an 80 and you add an extra value in there that's low, like a 5, it's going to pull the mean down. But if you look at those scores, right, is the mean going to accurately describe the performance of a typical student in that class? As you can see, none of the students failed the test except for the student that received the 5. But it's going to pull that average down, okay? So when I go back into the calculator and go back into stat, and I add that extra value in of a 5, okay? And then stat, calc, one variable stat, and enter. Now you can see that your X bar, your sample average, is 69.3. So the typical test score dropped by about 11 points. And that's not really a fair representation of how students performed on that test, okay? So the mean might not be a good measure of center in this case. Okay, so we know that the mean decreased. And I would say that it's not a good representation. Because if you look at the test scores, again, we have 1, 2, 3, 4, 5 students out of the 7, now including student number 7 that got the 5, that actually got a C or higher, but the average is a D. So that's not very accurate. So we need to look at another measure of center, and that would be the median, okay? The median, unlike the mean, is not sensitive to extreme values or outliers, right? And we said outliers are extreme values. The mean is sensitive, as you can see. When that number 5, which is an extreme value, it's not close to the other numbers, was placed in there, the mean dropped. But let's look at the median. So the median is the middle number when we rank the numbers, okay? So it's the middle number when list of numbers is ranked. And when I say ranked, I mean placed in some kind of order, highest to lowest or lowest to highest, it doesn't matter. Okay, so if I pretend that 5th person wasn't there for a second, right? If we were to take those original 6 test scores and order them, and then find the middle number, okay? Well, the middle number is actually 2 numbers, because if we cross off highest and lowest until we get to the middle, there's 2 numbers in the middle. So what I would need to do is find their average. And to find their average, I'm just going to add 78 and 82. And divide by 2. So the median actually comes out to be the same as the mean. So what that tells me is that the data at that point is symmetric, because anytime you have a symmetric distribution, the mean will be equal to the median, okay? Or they'll be like really, really, really close, especially if you're dealing with real life data, okay? If there's an odd number of values, like when I go and put that 7th person in there, the median is going to be the middle number still. So if I was to rank these, I would have 5, 68, 74, 78, 82, 87, and 91. Okay, what's the middle number now? 78. Okay, which is pretty close to 80. But it's a lot more accurate to use the median to describe the measure of center, because the median is not affected by extreme values. It doesn't care about the 5 or the 91. Okay, 91 is not extreme, but on either end, the middle number is always the middle number regardless. Okay, whereas the mean is affected by any of those extreme values. The mean will be distorted. It'll be pulled up or it will be pulled down. So the median, and by the way, we do have a symbol for median. It's has a little squiggle on top or a tilde. That stands for the median. The median here, when I place that 5 in there, is a 78. Okay, so as a statistician or an instructor, I would want to report the median and not the mean. Okay, so the median was not really affected because it's not affected by extreme values. Or we would say it's not sensitive to extreme values, whereas the mean is. The median is great to use when your distribution is skewed, okay, in either direction. So here I have 2 examples of dot plots. We have the dot plot on the top right. This is skewed right. And remember the other day we talked about how to tell what direction a graph is skewed in. So if you kind of make this into a fish, right, here's the tail, and the tail is on the right side, so the distribution is skewed right. When the distribution is skewed right, those extreme values on the right side are going to pull the average up. The median or the middle will still always remain in the middle. So when it's skewed right, the median will actually be less than the mean. Okay, the mean's going to be greater. When it's skewed to the left, as it is in this graph, okay, the mean or the average is going to be pulled down. So in that case, the median will be greater than the mean, okay, because again, the median's the middle number and it's not affected by the extreme values. So when you have a distribution that's skewed, it's best to use the median to describe the measure of center. And the mean is great when the distribution is unimodal and symmetric, and it doesn't have any outliers or extreme values. Now let's take a look at the measures of spread. So how do we quantify spread? Spread is literally how spread out the data is, from the lowest value to the highest value, okay? But the lowest to the highest doesn't tell me too much. A lot of times we want to know what's going on in between the lowest and the highest, okay? So there's an activity that we will complete in class where we will fill out this chart. For the sake of not having those data values to be able to look at, I'm just going to make up some numbers here. So one measure of spread is what we call the range. And the range is just how spread out the data is from the max to the min, or the highest value to the lowest value. If you'll remember in lesson 1.2, we actually looked at the range when we were creating a histogram, okay? So let's just take the numbers 1 through 10. If I have those numbers here, and I want to find the range is just the maximum minus the minimum. So my maximum value is obviously 10, and the minimum is 1. So it's a range of 9, okay? But the range doesn't really tell us what's going on in between the 10 and the 1. Okay, I just know that it's spread out, it's 9, which is not a large number, but unless you actually have the data to look at, you don't know that all the values are 1 away from each other. Okay, so that's where some other measures of spread come in. So another measure of spread is to look at what we call quartiles, and these are really important, especially when we are looking at distributions that are skewed. We're going to mention quartiles, as well as when we're making box plots, we need the quartiles, and also when we need to find outliers, okay, because we do have rules for finding an outlier, other than just making a prediction if the value looks like it's far away. We have rules that will give us specific boundaries that tell us whether a value is an outlier. Okay, so what we need to do to find quartiles, we're going to take the values that we have and we're going to line them up or rank them. Okay, so I'm just going to copy and paste this. Okay, so there's my values. If I want to find the quartiles, I'm going to look for 5 things. I'm going to find the min, which we already know. I want to find the max, so the lowest and the highest values. We know how to find the median, okay? And I also want to look for the first quartile, which we call Q1, and the third quartile, which is Q2. So essentially what will happen is we're going to take our data and divide it into 4 parts, okay? So first I need to find the median. Remember, the median is the middle number when the numbers are in order. So if I try to find the middle number here, you have an even number of numbers. The median is going to be in between 5 and 6. So to find the median, what I would need to do is I would need to add 5 plus 6 and then divide by 2. So I'm finding the average. It's just the number in between 5 and 6, which is 5.5. Okay, so my median is 5.5. I know my min is 1 and my max is 10. Okay, so now that I know that, I want to, like right here is my median. Okay, which by the way, the median is also known as Q2, or the second quartile. Okay, so what I want to do now is I'm going to look to find the first quartile. It's the median of the first portion of the data. So I'm going to look from 1 to 5, and I'm basically just going to find the median there. And the middle number there is 3. So that's my first quartile. And for the third quartile, it's the median of the second half of data. So the middle number from 6 to 10 would be 8. Okay, and 8 is my third quartile. Okay. So something I want to discuss really quick, because this will affect, finding quartiles. If we had an odd number of numbers, like let's say we just had 1 through 9. Okay, now the middle number is easy to find, right? The median would be 5. But do I include the 5 or do I not include the 5 when I'm trying to find the quartiles? Okay, so if you noticed, when I was finding the median for the 10 numbers, we really didn't include the median in our search for it. So same thing, I'm not going to include the median here. If I wanted to find Q1, I would not include the 5. I would just find the median from the numbers 1 to 4. So that would be 2.5. And then to find Q3, I would find the median for the numbers 6 through 9, which comes out to 7.5. Okay, so depending on what textbook you look at, sometimes the median is included to find quartiles, other times it's not. But it really doesn't make much of a difference. However, I would like everyone to stay consistent, because if you include the median, your calculator will be giving you a different value. Okay, so if we go back to the calculator, I can show you here on the TI-84. If you go into stat and you go to edit, Okay, I have those values in there now. If I want to clear this out, I'm just going to use the arrow up on top of L1 and then just hit clear. And now it cleared the column. We're going to type in the numbers 1 through 10. Okay, so now I have my 10 values, and to find that, we call it the 5-number summary, the min, the max, Q1, the median, and Q3. I'm going to, again, go back to stat, and then go to calc, and it's just one variable, it's just one column. Okay, click enter, and now you have your 5-number summary, as you can see, which tells me my min was 1, my max was 10, and it's got the values we found earlier. Quartile 1 is 3, the median's 5.5, and quartile 3 is 8. So when you are finding the 5-number summary, okay, which is right here, here's your 5-number summary, you're going to not include the median when you're finding the quartiles. Okay, so that's very important. Okay, so let's write that down. So we've got our 5-number summary here. So if you're ever asked to find the 5-number summary, those are the 5 values you're going to look for. And we don't want to include the median or Q2 when you are finding the quartiles. Okay, at this point too, if you'd like to, pause the video and try using your calculator. It's very good practice to try to get these values. The calculator is a great tool for large, sets of data. However, if it's really large, you would want to use some type of computer program instead. Okay, so basically when we were finding our 5-number summary, really what we were doing was dividing those 10 numbers into 4 equal parts, okay? So if we go back and we take our test score, the 6 students and the test scores, right? Actually, let's do the 7 students. So if we were to find the median of the 7 students, that's good practice. And in case you don't remember, the test scores were 5, and then we need to put them in order. So it would be 68, 74, 78, 82, 87, and 91, okay? So I would want to find the median, which is the middle number when the numbers are in order, right? So let's say I want to find the 5-number summary. My min is 5, my max is 91, and we know the median, or Q2, is 78. Okay, so that just chopped the data into 50%, right? So 50% of the values are to the left of the 78 and 50% are to the right of 78. Okay, that's what the median represents, is 50% of the data. So that just means that 50% of the students scored less than 78 and 50% of the students scored more than 78. Okay, to find my Q1 or my first quartile, I'm going to find the median of the first half of data. And remember, we're not including the median, so that would be the number 68. So there's my Q1. Okay, so the first quartile means 25, right? So 25%, so 25% of the students scored less than 68, or a quarter of them, and then that would mean that 75% scored more than 68. And then to find my Q3, or my third quartile, that represents 75% of the data, and that would be the number 87. Okay, so that means 75% of the students scored 87 or less, and then 25% scored more than 87. Okay, but now if you look at the data, if I kind of color code it, it comes out to be 4 parts, right? So here's your first part of the data, and then here's the second part of the data, and then here's the third part of the data, and then here is the fourth part of the data. Okay, so it cuts it into 4 equal parts. Okay, so what you will need to do, if you were in class, you will have looked at these two 5-number summaries for males and females, and then you're going to compare both of them. One other important concept or measure of spread that I'd like to talk about is what's known as the interquartile range, or the IQR. Okay, the IQR is always reported when you report the median as your measure of center. So to find the IQR, or interquartile range, if you think about it, range means subtract, right? And interquartile, it just means between the two quartiles. So if we look at our test score values, if I want to find the IQR, I would just take Q3 and Q1 and subtract them. Okay, so 87 minus 68. Those two values, by the way, contain the middle 50% of the values. So if we go back and look, right here, this represents the middle 50%, okay, from 68 to 87. So that's your IQR, or interquartile range. And again, it's the middle 50%. When we create a box plot, this will actually be the box part of the plot, okay, so that it's easily identified. So 87 minus 68 gives us 19. So our IQR, or interquartile range, would be 19 percentage points, okay, if we're looking in context of tests. Okay, so there is a difference of 19 percentage points between the third quartile and the first quartile of our data set for tests. Okay, so one of the things that you want to think about is 19, is that a large number or a small number? So if you consider it large, that means that there's a lot of variability. It means that the between the first and third quartiles, like there's a lot of change in the test scores. If you consider 19 to be a small number, then that means that there's not a lot of variability between the two quartiles. So in other words, the test scores aren't really variable. They're not changing much. Okay, now we only have a couple test scores in between, so it doesn't really tell us too much, but if we had a whole class set of test scores, we would be able to look at those values, and the interquartile range would represent whether there's a lot of change or not a lot of change in between those two values. Okay, so you can think about if you have a really large data set, like thousands of responses or numbers to look at, the interquartile range can tell you a lot. Whether there's a lot of variability, if you're thinking about, like, let's say polling for a presidential election, if your IQR is really, really large, it means that people really vary in their opinions of that person. If the IQR was small, if it was a small value, it means people's opinions are pretty consistent with what they feel for that person. Okay, so two last things that I want to go over with all of you is we talked about two measures of center, and right now we've talked about two measures of spread. So when you have the median, right, the median is used for skewed distributions when you report the measure of center. And anytime you report the median, you always want to report the IQR with it, okay? So those two go together. And again, that's for skewed distributions, okay? When you have distributions that are symmetric and unimodal and there's no extreme values, you want to report the mean for your measure of center, And then we're going to report something called the standard deviation, which we're going to talk about in a later video. The standard deviation is another measure of spread. It tells us how much variability there is in terms of the mean. So basically we'll be looking at like how do the data vary to the mean. So the mean and the standard deviation always go together. Anytime you report the mean for a bell-shaped or normal model, okay, so when we say bell-shaped, we mean it's unimodal and symmetric, and we refer to it as the normal model, and we'll look very much in depth at the normal model. We use it a lot in statistics to make estimations of populations. You will report the mean for your measure of center, and then you want to report the standard deviation for your measure of spread. Okay, and that is the end of the video. Please make sure you work on the homework. And again, at the end of the homework are the answers for the selected problems. And please feel free to ask me questions if you have any about the lesson. Have a great day, everyone.